Continuing with our session 3 of the TSI Math Prep. This third session we talk about word problems, which involve volume, area, Pythagorean theorem, probability, and statistics. So we have a word problem involving area. The size of one square is only 3 meters more than the size of a second square if the area of the larger square is subtracted from 4 times the area of the smaller square. The result is 36 meters squared. What's the length of the size of the larger square? Whenever we're working with any type of word problem, we always want to read the question to ourselves a couple of times, write down all the information we know about the question, and then if we can draw a picture. So in this particular question, we're dealing with two squares, a smaller square and a larger square. So we have a smaller square here, and then we have a larger one. Now we don't know either sides. Let's make this more of a square shape. Now we don't know either sides of the squares, but we know that the one square has a length 3 meters more than the side of the second square. In math, more means adding, addition, so we're adding onto it. So we don't know either side, but we know that the larger one is 3 more than the smaller. So we can call the side of the smaller square right here as x, and it means that the side of the larger square has to be x plus 3. Now, we're talking about area of the squares, so let's find the area of the smallest square first. It's called the A1. That would be side times side, which is x times x, which gives us x squared. A1. And A2 with the same thing, side times side, x plus 3 times x plus 3, gives us x plus 3 squared. That's A2. Now it says if the area of the larger square is subtracted from, so we're taking subtracted from 4 times the area of the smaller square, the result is 36 meters squared. So we're taking 4 times the area of the smallest square. So if the smallest square is x squared, the area of that, it would be 4x squared. We're taking away from, subtracted from, larger square, so that would be x plus 3 quantity squared, and the result means equal 36 meters squared. So we now have our equation, and this equation is set up as a quadratic equation, so we need to expand. First thing we do is x plus 3 squared is written as x plus 3 times x plus 3, so we have which is written right here. So we got to FOIL that. So if we were to FOIL that, you would get minus, the parentheses, x squared plus 3x plus 3x again plus 9 equals to 36. Now we combine like terms. We have to add the 3x's to get 6x, and then distribute the negative into everything on the parentheses. Minus x squared minus 6x minus 9 equals to 36. So we distribute everything inside the parentheses. Now we combine like terms again. So you see that the x squares can be subtracted. 4x squared minus x squared gets us 3x squared. So the rule for quadratic equations when we're solving is we want to get everything to one side. But we notice that all of the coefficients here, 3, 6, 9, and even the 36, can be all divisible by 3. So we want to do that just to make our equation easier to work with. So when we divide everything by 3, we get x squared minus 2x minus 3 equals to 12. Then we can take that 12 and bring it over to the left side. So it cancels there. X squared minus 2x minus 9 is equal to, I'm sorry, not minus 9, because we're adding. Just combine the negative 3 minus 15 equals 0. Now we want to factor the left side. Find two numbers that multiply to get you negative 15, but add to get you negative 2. That would have to be x minus 5, x plus 3 equals 0. Now that we've factored, we set them separately equal to 0. So x has to be 5 or x has to be negative 3. But because we're dealing with a real life problem, in this case we have to figure out what x represents. X represents the side of a square. So because we're looking at a measurement, a length, we can't have a negative length. So it means the only possible x would have to be 5. Now the question is, what is the length of the larger square? What we just found is the side of the smaller square. So x here is a side, smaller square. That means that x plus 3 would be the larger. And we're talking about the side, the larger side. So that means that to find the larger side, that would have to be x plus 3, which is 5 plus 3, which gives us 8. So the length of the side of the larger square would be 8 meters, which is answer choice A. Right, another one, area. Given the circle inscribed inside the square, find the area of the shaded region. Let pi equals to 3.14. Round your answer to the nearest whole number. So we have two shapes here. We have our square on the outside and a circle that's inscribed inside that square. And we want to find the area of the shaded region. So if you notice, what we're looking at is we have two areas we need to find first. The area of the square and the area of the circle. So area of a square, as mentioned before, is just side times side. So if we look at this shape here, this diameter here stretches across one side of the square to the other. So it's safe to assume that the side of the square would be 12. So the area of the square would be 12 times 12, which gives you 144. Now the circle is, to understand what the area of a circle is, the area of a circle is pi r squared, where pi is the unit pi, which is represented 3.14 in this case. R is the radius. Radius is half of the diameter. So our diameter is the length from one side of the circle to the other. That. So our diameter in this case is 12. Half of that, the radius, would have to be 6. So that means our area would be 3.14 times r squared, which is 6 squared. So that's the area of our circle. Now to find the shaded region, what we do is we take the area of the square and we subtract away the area of the circle. So shaded region would be area of the square, because that's the larger area, subtracted from the smaller area, which would be the circle. So basically, you're taking that circle and you're removing it from the square, and you should be left with that blue, that navy blue shaded region. So 144 minus 3.14 times 6 squared. So it'll be 144 minus, so we use our calculator here, 6 squared, we know that is 36 times 3.14. That's 113.04. So if we subtract those two, 144 minus 113.04 gets us 30.96. But they want you to round your answer to the nearest whole number. I get to 31. So the area of the shaded region should be 31, which is answer choice C. Okay, moving on with a different one, this time involving the Pythagorean theorem, and you'll see in a minute why it is a Pythagorean theorem. A ladder is resting against the wall. The top of the ladder touches the wall at a height of 9 feet. Find the length of the ladder if the bottom of the ladder is 12 feet from the wall. So again, you always want to draw a picture. So we have a wall. Let's call this wall that's standing right here. It's our wall. And we have a ladder that rests against it. It says the top of the ladder touches the wall at a height of 9 feet. So if this is the top of the ladder here, it touches the wall at 9 feet. Find the length of the ladder, so we're looking for how long the ladder is, if the bottom of the ladder is 12 feet from the wall. So if this is the bottom of our ladder here, we can draw a line here. That means that's 12 feet away. So we're looking for this unknown length of the ladder. So this right here is a triangle shape, and not only is it a triangle, it's a right triangle. And the theorem we know that goes with the right triangle is the Pythagorean theorem. So the Pythagorean theorem states is if you have a right triangle and you have two legs here, let's call this leg A, let's call this B, and then the hypotenuse, which is the long side, is always C. The Pythagorean theorem states that we have A squared plus B squared, that must be equal to C squared. So applying that to our picture here with the ladder, our A is 9, our B is 12, and our C is X. So plugging it in, the Pythagorean theorem, we have 9 squared plus 12 squared gets us, X squared. So solving for X, we evaluate 81 plus 144 equals X squared. So if we add up together, this would be 225 equals X squared. So to solve for X, we want to take a square root both sides to get rid of that square there. So for X and square root of 225 is 15. So the length of the ladder is 15 feet. And that's how you use the Pythagorean theorem to solve this question. The answer is D, 15 feet. Right, now we're talking about perimeter. Find the length of a rectangular lot with a perimeter of 82 meters if the length is 5 meters more than the width. So we have a rectangular lot, and a rectangle consists of a length and a width, longer side of length, shorter side of the width. We know that we don't know either length or width, but we know that the length is 5 more than the width. So whatever the width is, you would add 5 to it to get the length. So let's call the width is just W. So that means the length would have to be whatever the width is plus 5. Now the perimeter, it tells us that 80 is equal to 82. Now to find out what the perimeter of any shape is you add up all sides of that shape together. Or in this case, for a rectangle, we know that a rectangle has 2 lengths and 2 widths. So we can say that the perimeter is 2L plus 2W. You can always add them all together, but it looks better if we plug it into using that formula 2L plus 2W. So now when we plug it in, our perimeter 82 is equal to 2 times our length, which is represented by W plus 5, plus 2 times our width, so we just call that W. So now we have an equation with just one variable. We can now solve for that variable. First thing to do is distribute 2W plus 10 plus 2W, 82. Combine like terms on the right, we can add the 2 W's, we get 4W. Get W by itself, so we subtract both sides by 10. It cancels, so 72 4W. And then we divide both sides by 4. So that tells us that 72 divided by 4 gives us 18. The width is 18, but you always want to go back and see what the question is asking for. We found the width, but is it what it's asking? The question is find the length of the rectangle. So what you do is we take this width, we plug it in to W plus 5 to find the length. 18 plus 5 gives you 23. So that is the actual question answer we're looking for. The answer choice is B, which is 23. Okay, so now we're dealing with another type, but with volume. So we're talking about a 3-dimensional shape this time. So the height of a box is 7 inches. Its width is 6 inches less than its length. Find the width of the volume if the volume is 280 cubic inches. So what we're looking at is a box, a rectangular box to be exact, because that's the width and the length. So when we're talking about any type of volume of a rectangular box, we know the formula to find the volume. It's like the area, just adding another dimension to it, which is the height. It's length times width times height. Now let's see what we have. We know right away that the height is 7 inches. As we know, the height's 7. We don't know the length or the width, but we know that the width is 6 inches less than the length. So whatever the length is, you subtract 6 to get the width. So let's call the unknown length x. Then in w would have to be x minus 6, because our length is our independent variable. And then we know the volume is 280. Okay, so now we know all the components we need to plug into our formula. Let's go over here and plug it in. So we have 280, which is our volume, equals the length times width times height. Okay, so before we try to multiply the right side, we notice that 7 here can be divisible by 280 right here can be divisible by 7. So let's go ahead and just get that out of the way first and divide both sides by 7. Because in doing so, cancels this, and then 280 divided by 7 gets us 40. So it makes things a little bit easier for us to multiply. Now if we distribute, x squared minus 6x equals to 40. Now we're dealing with another quadratic. Bring everything over to one side. Subtract 40, subtract 40. So x squared minus 6x minus 40 is equal to 0. Now we can factor. Think of two numbers that multiply gets you negative 40, but add to get you negative 6. So we have x minus 10 and x plus 4. Set them separately equal to 0. Oops. So solving them, we get x equals 10 and x equals negative 4. But again, because we're dealing with a length, that's what x represents. Can't have negative length. So we exclude that x equals a negative 4 right away. And we want to think about it. We now know that right here our length is 10. But that's not what we're looking for. We're looking for the width. Find the width. So we would plug it in over here. The width would be 10 minus 6, which gives us 4. So always be very careful about what the question is asking for. The answer is 4. But if you notice, C is 10. So that's a common misconception that we always do, because we always tend to, once we finish the answer, we want to go straight to the answer that we got, which is 10, but that's not the case. That's the length. It's not the width, which is that's asking for. Okay, now moving on to something a little bit different. We're talking about probability statistics. So basically, these, when we're talking about statistics mainly for this, it involves some definitions that you have to know. So there's 4 main ones you have to know: is mean, median, mode, and also range, which is on the next slide. So I'm going to go over these definitions real quick. Mean is the mean of a quantity of data is equal to the sum of all the measurements divided by the total number of elements in the set. You want to think about it as average. So to find the average of something, you add everything up and you divide it by however many numbers there are. The median is the middle measurement when the data is arranged in ascending or descending order when a data has odd number of elements. So if the data has even number of elements, then the median is the average between the two middle values. Mode is the most frequently occurring measurement in a data set. So going back to what the median is, median basically is you order it from least to greatest or greatest to least, and then you kind of basically cross out both sides until you get to the middle number, and that would be your median. But if you have two numbers in the middle, after you cross things out, what you do is you take the average of those two. So you add them up, divide them by 2. The mode is most basic one. You basically see which element shows up the most in the set. So if you have 1, 2, 3, 4, 5, and another 1, the mode of that set would be 1 because there's 2 of them. And now range, the difference between the highest and lowest measurement in the data set. So you take the highest number, subtract it by the lowest number in the set. That's usually what it means. And then now we're talking about probability. So probability is the chance or likelihood that something happens in the future. The values of probability are always between 0 and 1, and is represented by this P of E, so probability of some event, is equal to the number of outcomes in that event over the total number of possible outcomes. So you want to think about what's the chance of you doing something. So the most basic example is we're talking about coins. If you were to flip a coin, let's say, what is the probability of you getting heads? So first thing you want to think about is the bottom of our fraction here, because our probability always some type of fraction. The bottom of the fraction is the total number of possible outcomes. So you want to think about how many total possible outcomes are there for a coin. Now, a coin has two sides, so that means that there's only two possible outcomes. And now you want to think about the top of the fraction be the number of outcomes in the event E. E in this case would be heads. So what's the number of outcomes you can get heads? It's only one, because coin has one side, or two sides, only one side has heads. So the probability of you getting heads is 1/2, or 0.5, or 50%, depending on what the question is asking for. So that's basically what probability is. So these are some useful definitions you should know when working on these type of problems. All right, so now let's apply those definitions. So consider the following 12 data points. What's the range of these data points? So range, as mentioned in the last slide, is the difference between the largest number in the set and the smallest number in the set. So first thing you want to do is you want to identify your largest number. So we'll look here. The largest number is 18. That means that what you do is you would subtract by the lowest number. The lowest number would be 9. So our range here would be 18 minus 9, which gives us 9. Simple as that. So the answer choice is A, which is 9. Now, some probability questions. So a fair dice is rolled. What's the probability the number shown is not 4? So you want to consider, so what you want to do is you want to consider your dice. You know your dice has 6 sides. Normal dice, at least, is 6 sides. And the dices are 1 through 6. So now the question is, what's the probability of it not being 4? So the sides that aren't 4 are 1, 2, 3, 5, and 6. So it'll be a total of 5 sides that are not 4, and then 6 of them out of 6 total sides. So the probability will be 5 out of 6, which is answer choice C. Another fair dice. What's the probability that it shows a number that's a multiple of 3? So again, we look at our possible sides. Oops, missed a 5 there. So we see which of these are a multiple of 3. So multiple of 3 is any number that can be divisible by 3. So we only have 2 numbers out of those, which would be 3 and 6. So the probability of it being a multiple of 3 would be 2 total sides out of 6 total options. 2 out of 6, but because we always have to reduce our fraction, we can divide top and bottom by 2. We get 1 out of 3. So we have 1 out of 3 chance of rolling a dice that's a multiple of 3. It's choice A. Okay, so now moving on with a deck of cards. So a card is drawn randomly from a deck of ordinary playing cards. You win $10 if the card is a spade or an ace. What's the probability that you will win the game? So first thing you want to do is you want to see what is, in this particular question, the extraneous information. What information does not matter in this case? The one that doesn't matter is right there, the $10. We don't care how much money we win. We're looking for the probability we will win. So we automatically just exclude that information. Now you win the game if you draw what you draw as a spade or an ace. Keyword is or. In probability, or is always represented by addition, and is always multiplication. So whenever you see those type of questions, you want to think about those signs, those operations. So probability of you getting a spade or an ace. So you have to understand what a normal deck of cards looks like. So from background information, standard deck has 52 cards. There are 4 suits, which are spades, club, hearts, and diamonds. And each suit has the same type of cards. They are the number cards 2 through 10, Jack, Queen, King, and Ace. So which makes a total of 13 cards per suit. That means 13 times 4 gets us 52 cards. So probability of getting spade or ace, because we're talking about or means addition, we can basically just find what's the probability of a spade and add that to find the probability of aces. So probability of spades. We know there are 13 spades in the deck. So the probability would be 13 out of a total of 52 cards. Now aces. We have an ace in each suit. So ace of spades, ace of clubs, ace of hearts, and ace of diamonds. So we have 4 aces. But one of those aces, it's already in here. It's one of those 13 spades. Because the ace of spades is a spade. So because of that, we have to think about what are the remaining ones. The remaining ones would be the ace of clubs, ace of hearts, and ace of diamonds. So there are only 3 left out of a total of 52. Because we can't just say we double up on our cards. We're looking at a standard deck. Ordinary playing cards. We're not looking at a trick deck. So now that we know our probabilities, and we know that we see that our fractions are, our denominators are the same, we can just add them. 13 plus 3 gets us 16 out of 52. And always reduce. We know we can divide by 4, top and bottom. Gets us 4 out of 13. So the probability of you drawing a spade or an ace is 4 out of 13. Which is answer choice C. Okay, another one. A bag contains 4 red marbles, 10 blue, and 6 yellow. What's the probability you will select at random a marble that's not red? So we're looking for the probability that's not red. So the marbles that are not red would be the blue and the yellow ones, which would be 10 plus 6. And of a total of how many marbles. So to find out how many marbles there are, we just add up all of them. So 4 plus 10 plus 6 gets a total of 20 marbles in the bag. So 16 over 20. Now, normally you would try to reduce your fraction, but if you go back to the question, the answer choices are all decimals. So we have to somehow convert this into a decimal. Let's say we didn't have a calculator. The best way to convert into decimals is think about percentages. Every percentages is always out of 100. So we can say, hey, let's find a fraction, turn this to a fraction that's over 100. So to go from 20 to 100, you multiply by 5. So what you do at the bottom, you got to do to the top. Multiply 16 by 5 as well, which gives us 80. So 80 over 100 is like saying 80%. And to turn that to a decimal, you move the decimal 2 to the left. Gets you 0.8 or 0.80. So our answer choice is 0.8. So that's usually how we convert fractions into decimals if we didn't have a calculator. Get it over 100. Okay, so now we have another bag. This time we have 6 red and 4 black marbles. 2 marbles are drawn with replacement from the bag. What's the probability that both marbles are black? So you want to think about what does it mean by with replacement. So that means that whatever in your first draw, you pull out whatever the marble is, then you put it back in for the second draw. Then you do the second draw. So we have 2 different things, 2 independent events of 2 draws. So this is our first draw and our second draw. On our first draw, we're finding out what's probably it's a black marble. So it would have to be 4 out of a total of 10 marbles. And then same thing, right? For the second draw, because we took out, let's say we drew a black marble, we put it back in, there should still be the same amount of marbles, and that means that there would also might be a chance of the same event of total marbles. So we have 4 out of 10 and 4 out of 10. So what we do now is, because they're independent events, we multiply them together. So it gets us 16 out of 100. So we reduce, we divide by 4 top and bottom. 4 out of 25. So that's the chances of you drawing both marbles that are black. So 4 out of 25. Now what if you were in the same situation, but this time it's drawn without replacement? Without replacement. So what does that mean? So we do it just like we did before. First draw and second draw. So the first draw just stays exactly the same. Our probability of getting a black marble be 4 out of 10. But once let's say for instance we do draw that black marble, we don't put it back in. That means that everything is taken away by 1 because there's 1 less marble in the bag now. So you want to think about your second draw is you want to try to get another black marble. But how many blacks are left? There's only 3 black marbles left because you took 1 out. And then how many are left in the bag in general? There would only be 9 now because you took that black one away. So the probability of getting a black marble on your second draw would be only 3 out of 9 now. So because again they're independent, we multiply them together. 4 out of 10 times 3 over 9. So we can always reduce here. 4 and 10. So let's actually do it like this. Yeah, that's fine. So it'd be, we can reduce 4 out of 10. That gives us, divide 2 at top and bottom. We get 2 out of 5 times 3 over 9 can be reduced as 1 over 3. Then we multiply. We get 2 out of 15. So the chance of you drawing 2 black marbles, if you don't replace, would be only 2 out of 15, which is answer choice C. So you always want to read these questions carefully if it has with replacement or without replacements, because what happens is it changes what type of probabilities we have. Okay, so now we're talking about what is called a probability distribution. The number of adults living in homes on a randomly selected city block is described by the following probability distribution. What's the probability that 4 or more adults live in the same home? So we have this little table here. This table tells us that we have different probability distributions. So if the number of adults, if there's 1 adult in the house, the probability is 0.25. If there's 2, it's 0.50. If there are 3, it's 0.15. And there's 4 or more, that's what we're looking for. So for probability, the distribution should always add up to equal to 1. So basically what that means is to find the probability of 4 or more, you have to add up the other 3 probabilities and do 1 minus that. So it would be 1 minus probability of 0.25 plus 0.50 plus 0.15. Because everything has to be equal to 1, to find the remaining one, you add them up and subtract 1 from that. So you get 0.25 plus 0.50 is 0.75, plus 0.15 is 0.9. So 1 minus 0.9, which gives us 0.10. So probability of you getting, sorry, not you getting, probability of 4 more adults living in the same home would be 0.10. Which is answer choice A. Okay, so now we're going back a little bit with ratios. So Chuck travels 174 miles to Chicago. In the same amount of time, Dana will travel 159 miles to meet him there. Chuck's rate is 5 miles per hour more than Dana's. What speed does Chuck travel? So the ratio we're talking about in this particular case is speed. Speed can be represented by rate, R, So speed is equal to R, which is equal to, if you think about on your speedometer, it reads miles per hour. So that's like your distance divided by your time. D over T. So that's what we're talking. That's kind of what we'll be using for this question. So we have two people. We have Chuck and we have Dana. Now let's write some information down with both these people. So we know Chuck traveled 174 miles. So his distance, D, is 174. Dana, her distance is 159. Chuck's rate is 5 miles more than Dana's. So whatever his R is, it'll be 5 more than Dana's. So let's call Dana's just X, because we don't know what hers is. That means that Chuck's rate would have to be X plus 5. Now, what do we know about the times? We don't actually know how long it took them to get there, but it does say that it took them the same amount of time. So their times are equal here. But if we don't know what their times are, we can actually change this rate equation here and make it T equals instead of R equals. So that by doing that, we multiply both sides by T. We would have TR equals to D and divide by R. So we have time can be represented by distance over rate. So in doing that, let's figure out what Chuck's time is. So Chuck's time can be represented by his distance over his rate. Same thing for Dana's. Her distance over her rate. So 174 over X plus 5 for Chuck's time, and Dana's is 159 over X. Now we know their times are the same. Because their times are the same, that means that their two times can be set equal to each other. So we can say that 174 over X plus 5 is equal to 159 over X. So we now have a ratio question. To solve this, what we can do is we can cross multiply 174 times X equals to 159 times X plus 5. So if we distribute that right side, we have 159X plus 795. So we're dealing with just a simple linear equation. To solve for X, we subtract both sides by 159 to bring it over to the left side. So 174 minus 159 gets us 15. X. Oops, I'm sorry, that's 795, my bad. And then to solve for X, we divide both sides by 15. So that gives us X equals 53. Now, let's go back though. We have to figure out what does X represent. X represents Dana's speed. But the question is asking what is Chuck's. So to find Chuck's speed, you would take Dana's and then add 5 to it, because he's traveled 5 more than Dana's. So it would be 58 miles per hour. So that would be Chuck's speed. Like we said before, always go back to your question and reread what it's asking for. So the answer is B, 58 miles per hour. And again, you see that D, 53, Dana's speed also shows up. So you always want to double check. Okay, going back to some system of equations here. System of linear equations to be exact. Solve the following system of equations. 2x minus 3y equals 0 and negative 4x plus 2y equals negative 8. So we've done something like this before in the first video. To solve system of equations, there's two ways to do it. Either you use substitution or elimination. Now we actually apply elimination to this question because elimination, what it does is you want to get rid of one of your variables, either x or y, depending on what the situation of your equations are. For this one, we can get rid of x. The reason is because in order to eliminate variables, we have to basically add up the two equations, and once you add them up, it would potentially get rid of either x or y. But in order to do that, we can't add them as they are now because there's nothing that cancels out. But if you look at the x's, 2x is negative 4x, we can actually do something with that because we can actually multiply the first equation here by 2. Because when we do that, 2x times 2 gets us 4x, and we add to negative 4x, that gets you 0. So that would be how we do it. We always want to analyze which would be the most advantageous variable to get rid of. So when we multiply this, we would have, we have 4x minus 6y equals 0. Make sure you multiply everything by that 2 on the first equation, and then the second equation stays exactly the same. Okay, now we add up the two equations. We notice that this becomes 0x, which is basically 0. Negative 6y plus 2y is negative 4y, negative 8. So basically we have negative 4y equals a negative 8. Divide both sides by negative 4. So y gets us 2. So we solve for y, but when we're solving for a system of equations, we have to solve for both x and y. So to take this, what we do is we take this and we plug it back into either equation. Doesn't matter which one. Let's say we plug into the first one to make it easier for ourselves. So we have 2x minus 3 times y, which is 2 we just found. So we have 2x minus 6 equals 0. Add 6 both sides. Divide by 2 to get x by itself. So x has to be 3. So that's our x, that's our y, and they usually write it in a coordinate system, so it'd be 3, 2. That would be our solution set, which is answer choice A. Okay, so now going another word problem that involves a quadratic equation, and we'll see why. The sum of the squares of two consecutive integers is 41. Find the integers. So when we're talking about, let's kind of read each, term and try to translate that into some type of equation here. So sum we know is addition. Squares is anything raised to the power of 2 with exponent 2. Now two consecutive integers. So integers means any whole number. Now consecutive is a word we have to make sure we understand. Consecutive means one after the other. So 1, 2, 3, 4, 5 are all consecutive numbers. So we don't know either integer. So let's call our first number as just x, because it's unknown. If that's the case, we have to figure out what the second number is. The second number will be the consecutive integer after x. So if you think about 1, 2, 3, 4, you add 1 each time to get to the next one. So that means that if the first number is x, the second number would be adding on to it to get to x plus 1. So those are two numbers we don't know. The sum of the squares is 41. So that means the first number squared plus the second number squared is equal to 41. So that is the equation form of what that first sentence says. That's how we translate that into an algebraic equation. Okay, so now we solve that equation. So remember, x plus 1 squared, it's like saying x plus 1 and x plus 1. So we would have to expand that by foiling. So when we FOIL, we get x times x squared, x times 1 is x, 1 times x is another x, and 1 times 1 is 1. So remember that foiling comes from, we did that a lot in the second video. So make sure you remember that. And then the x squared, the other x squared I brought it down from over here. That's equal to 41. Okay, so now we want to combine like terms. We see that x squares can be added to x squared. And then we have x and x, that's 2x plus 1 is 41. Because it's a quadratic equation, we want to bring everything over to one side. So subtract both sides by 41. So 2x squared plus 2x minus 40 equals 0. And we notice that everything can be divided by 2. So let's go ahead and do that just to make it easier to factor. We get x squared plus x minus 20 equals 0. Let's go up here so we get a little bit more space. So now we need to factor. So we think of two numbers that multiply get you negative 20, but add would get you positive 1. That would have to be x plus 5 and x minus 4 equals 0. So set them separately and solve for x. So that means x has to be negative 5 and x has to be 4. So now we have to consider, what does x represent? X represents our first number. So in this case, we have two instances basically. We have the first instance when x is negative 5, our first number, and the second instance is if 4 was our first number. So because of that, can't have a split here. If the first number is negative 5, the next number, the second number, would have to be a consecutive one. So they would have to be x negative 5 plus 1, which is negative 4. Same thing on the other one. Now, if the first number is 4, the next number would have to be 4 plus 1, which is 5. So we have two different sets now. So we have x is equal to negative 4. I'm sorry, let's write the other one first. Negative 5 comma negative 4. Or we have x equals 4 and 5. So you have to consider both pairs basically. So you see 4, 5 or negative 4, negative 5. So you have to be careful because if you look at A and D are also possible answer choices. But you have to consider because our x is, we got two answers for x. We got 4 and we got negative 5. But we have to consider that those are two specific different cases. And that's why those different cases result, the next consecutive number will be two different numbers as well. It will be negative 4 and positive 5 is the next number after those.